Hi everyone, this is going to serve as your Algebra 2 tutorial before your test that you're going to be taking tomorrow. Your test tomorrow is going to be through lesson 82. I'm going to start by going over a few things that I have seen on your last few tests that have not been going well and review those things as well as give you some problems to practice on your own. You're going to submit all of your notes from this video as well as any problems that I've asked you to do to my email by tonight at 11:59 p.m. So the first thing that we're going to look at is lesson 74, which is on your distance problems, and this one is specifically the uniform motion with both distances given. I'm going to start by going over the example 74.2, which says that Atalanta ran 4 times as fast as her challenger. In fact, she ran 80 miles in 2 hours less than it took her challenger to run 28 miles. How fast did each of them run? How long did they run? So we're looking for their rates and times of both. I'm going to start by just listing the information that I've given. It says that Atalanta ran 4 times as fast as her challenger, which means that Atalanta's rate, so the rate of Atalanta, is going to be 4 times the rate of her challenger. Then it goes on to say that, in fact, she ran 80 miles. So that means the distance of Atalanta is going to be equal to 80. Then it says, in 2 hours less than it took her challenger to run 28 miles. So I'm just going to go to distance of challenger would be equal to 28 miles. Now I'm going to look at that second part of that sentence where it talks about the time. It says she ran, so Atalanta ran in 2 hours less than her challenger. So that means the time of Atalanta is going to be 2 hours less than her challenger. So it would be time of Atalanta is equal to the time of the challenger minus 2. Now, based off of what we know for distance equations, we know that distance is equal to rate times time. So at this point, I'm going to change my dA and my dC to RATA is equal to 80. Unless RCTC is equal to 28. Now, if you look at these two rates and times that we are given, they're actually both the same subvariable, meaning that they both have the little letter A. And that's what we want. We want to be able to plug these into the same equation. So I'm going to take this RA, plug it into the RATA equation, and I'm going to replace my TA with TC minus 2. Now I can distribute my 4RC, and that would give me 4RCTC minus 8RC is equal to 80. Now what I should recognize here is at this point, there's really nothing else I can do with this equation. But I look over here and I see that RCTC is equal to 28. So I'm actually going to plug that into my equation. So I have 4 times 28 minus 8RC equals 80. And now I'm only left with one unknown. I'm only left with my RC. So I'm going to multiply my 4 times 28. And that gives me 112, and I'm going to move it to the other side. That would give me negative 8RC is equal to negative 32. So now I know that the rate of the challenger is equal to 4. Once I've solved for one of my unknowns, it becomes pretty simple to solve for the rest of my unknowns. So I can take this RC and plug it into this equation here so I can solve for TC. So that would be 4 times TC is equal to 28. And therefore TC is equal to 7. Then now that I know RC and TC, now I can come up to these two equations up here to solve for RA and TA. So RA is going to be equal to 4 times RC, so 4 times 4. So the rate of Atalanta is going to be equal to 16. And then for my time of Atalanta, TA is equal to TC minus 2. So that means the time of Atalanta is going to be equal to 5. So I want you to try this by working on page 310 and do the practice problem. So this is your chance to practice what we just went over. Now the next thing that we're going to look at is I just want to review some terms that you may or may not see on your test. Just so you know, ratio is just another word for fraction. So if I say the ratio of two numbers was equal to 1/2, that would be x1 over x2 is equal to 1/2. And if I said that the sum of two numbers, that means we're going to use addition. If I say the sum of two numbers, so let's say x1 plus x2 is equal to 9, you should be able to solve for x1 and for what x2 is equal to. So for this top one, for ratio, you could cross multiply that and get x2 is equal to 2 times x1. And that's what you're going to plug into your equation here for your sum equation. So those are just two things to remember. Fraction is just another word for ratio, and sum is just a word for addition. There's no practice problem for that one. We're just going to move on from there. So now we're going to look at lesson 77. Lesson 77, we are looking at the multiple radicals inside of one equation. So I'm going to look at example 77.2. 77.2, and this is going to be on page 321. So we're on page 321. And the example 77.2. So the equation that we're starting with is square root of k minus 5 minus the square root of k plus 1 is equal to 0. So your goal, your first goal, is to get the square root by itself, to choose one of them and to get it by itself. So I'm going to choose this square root right here, and I'm going to move everything over to the right-hand side. So this would give me k minus 5 on the left. On the right-hand side, I'm going to get the square root of k and minus 1, because if I take this negative square root, move it to the other side, and the positive one to the other side, the signs are going to change. Now to get rid of your square root, you're going to square both sides. So if I square this, I'm going to square the right-hand side as well. Now you're going to notice that on the left-hand side, your square root is going to go away, so you just have k minus 5 on the left. But on the right-hand side, you do have to multiply this out fully. So you multiply out square root of k times square root of k, which would just be k. Then you have k square root of k times negative 1, so negative root k. Then negative 1 times root k again, so negative root k. And then negative 1 times negative 1 would be positive 1. So what you should see at this point is that both of the k's are going to cancel out. But what I want is I have to get the square root by itself again. So I'm going to start by moving the 1 to the other side. So I'm going to subtract 1. That will give us negative 6 is equal to negative 2 square root k. So I'm trying to get that square root of k by itself. So I'm going to divide both sides by negative 2. And that will give me 3 is equal to the square root of k. Now, you get rid of the square root by squaring both sides. So I'm going to square both sides, and I get k is equal to 9. But you're not done yet, because you have to check your answer. Whenever your problem starts with a square root in it, you do have to check your answer. So on the side here, I'm going to say check, and I'm going to plug in my k is equal to 9. To the original equation. So that would be 9 minus 5 minus the square root of 9 and then plus 1, and I'm checking to see if that's equal to 0. 9 minus 5 I know is equal to 4. The square root of 9 is 3 plus 1 is equal to 0. Now the square root of 4 is 2 And then negative 3 plus 1 would be negative 2. So I now see that the left is equal to the right, so therefore k is equal to 9. Now I want you to try a problem like this one. So I'm going to give you problem set 80, number 7, so that you're able to check your answer in the back of your book. Unless otherwise specified, you are able to check your answer in the back of the book for the problems that I am giving you to practice. So now moving on, we're going to look at problem set 79 on page 327. So on page 327, we are given a couple new unit multipliers. So this is going to be, these unit multipliers are 1 liter equals 1,000 cubic centimeters, so centimeters cubed. Also, 1 centimeter cubed is equal to 1 milliliter. So that's something you need to know. And the example that I'm going to do is going to be example 79.2. Example 79.2. And that's on page 328. So the example that I have is 4 cubic feet to liters. So 4 feet cubed, and I'm trying to get this, so feet cubed to liters. I know that I am going to end up using this unit multiplier here, which means that I need to get this from feet to centimeters. So to go from feet to centimeters, I am going to start by going from feet to inches. So there are 12 inches in 1 foot, but don't forget that we have to cube that because of the feet cubed. Then I'm going to go to centimeters cubed because I want to use this unit multiplier again because I have to get to liters. So this would be 2.54 centimeters over 1 inch. And again, we have to cube that. And then my last unit multiplier would be this one given, which is 1,000 cubic centimeters would be equal to 1 liter. And that's over 1,000 centimeters cubed. So what you should see is that my centimeters are going to cancel, my inches cancel, and then my feet cancel. My answer would be 4 times 12 cubed times 2.54 cubed, and that's over 1,000. And your answer would be in liters. Now the problem that I want you guys to do is from problem set 79, number 7. And the last thing that we are going to look at is direct variation as a ratio and inverse variation as a ratio. And this is from lesson 80. So lesson 80. So something that I'm going to talk about here is when we have a problem that says A varies directly to B. So anytime we have the words that say directly, this is what your formula is going to be. It will be A1 over A2. Remember that your letters all stay on one side. So it would be A1 over A2 would be equal to B1 over B2. So this would be directly. Now if it says inversely or indirectly, it's just going to flip the second fraction. So this would be A1 over A2 stays the same. But instead of B1 over B2, it will be B2 over B1. So those are the two key things that you need to know from lesson 80. So directly versus inversely or indirectly. These are your two different formulas that you're going to use. Notice that the letters stay on the same side. So A over A, B over B, A over A, B over B. It's not switching sides at all. So I want to look at example 80.3. 80.3. So on page 332. And that example says blues varied inversely as yellows. So first of all, I'm using inversely, so I know that I'm going to use this formula. But instead of A1 over A2, it's saying blues are varying inversely. So that means I'm going to use B1 over B2. And it's varying inversely as yellows squared. So instead of B, I'm going to use Y because it's yellows. So I'm going to have Y2 over Y1. But the other thing I need to recognize is that it says yellows squared. So that means that I have to square both of these values. And now when I input my variables, I just need to remember that whenever I plug in the yellow, I have to square it. So it says that if 100 blues go with 2 yellows, that's my initial. So my initial blue was 100. And my initial yellow is 2, but don't forget I have to square it, so that would be 2 squared. Then how many blues go with 10 yellows? So I don't know the blues, but I do know that I have 10 yellows, so that would be 10 squared. Now to solve, you're going to cross multiply. So I have 10 squared, which is 100, so 100x is equal to 100 times 4. Now, if you divide both sides by 100, you're going to see that the number of blues is going to be equal to 4. So you can say 4 blues. So this is your key right here, is your directly and inversely to choose what equation. Just make sure you're paying attention. So if it says inversely as blues squared or blues cubed, that's going to alter this by just squaring it on this one, or if it said cubed, you'd cube it. So now what I want you to do is you are going to be practicing this. I want you to practice this on the practice B. Practice B, and that is on page 333. Now, obviously, this isn't everything that's going to be covered on your test. These are just some of the key things that I picked out that you guys have either been struggling on or something that I thought you should know. But there's going to be other things on the test. It's going to be 10 questions. I would, if you wanted to study more, look at lesson 82 and just go through some of those problems from that lesson and make sure that you understand those. I will be doing another tutorial for your test on Friday, and that will come out on Thursday. Have a great day.